Hi viewers, this is Sri Ramlu. So today's topic is electric field. So this electric field is taken from electrostatic, right? So the definition of electric field is the region surrounding an electric charge or a group of charges in which another charge experience a force is called electric field. For example, let there are the group of charges or a single charge, right? Around this charge, what happens? Field will forms. If you bring any positive charge from other side into this region, then what happens? It may experience a force. Here, what type of force it experience? Repulsive force. Or if you bring a negative charge and if you keep inside it like this, then what happens? It experiences a force, that is attraction force, like this. So whatever it is, whether it is a positive or negative charge, it experiences a force. So that region, that surrounding region is called electric field. So this region is called electric field. So this region forms around a positive charge only. So we can take a negative charges also, but mostly in electrostatic we have to define the definitions with positive charges only. Next, electric field lines. So what are the electric field lines? See here, an electric field lines is that imaginary smooth curve drawn in an electric field along which a free isolated positive charge will move. Right? Electric lines is the imaginary smooth curve. It is imaginary, not real. It is a one curve. It is drawn from electric field along which a free isolated positive charge will move. See, it is a isolated positive charge, it is isolated negative charge. And for the isolated positive charges, see here, the diagrams are drawn. So here, if you observe, lines of forces for the positive charges are always outwards, right? For lines of forces for the negative charges are always inwards, but here they are not curved, they are straight line. Okay, when they are isolated they are straight line. Isolated means when they are single, then only they shows a straight line direction. Otherwise there are the two charges, opposite charges, then what happens? Electric lines starts from positive charge and ends with negative charges. So this travels in this direction. Now it is a curve, like a curve, like this side also. Or suppose there are the same charges, not opposite charges, let there are the same charges. For the same charges, see the diagram, there are the two same charges are there, like this. Then what happens? Same charges, what happens? Repulsion will start. So here the lines of forces are moving in this direction, like this, right? So for this, so here these are bending of lines of lines of electric fields can indicates they are repulsing. So there is a repulsive forces. Okay, right? That is why they are shown in this manner. Next, the tangent drawn at any point on it gives a direction of the field at that point. See here, it is a one curve is there. If you want to know that its direction at this point, then draw one tangent, means one line which touches that point. So at this point, its direction is this is the direction. Figure A B shows that when the charge is isolated. So these two indicates when the charge is isolated. Figure C and D shows that when two charges are nearer to each other. So like this, these two are. Next, intensity of electric field. What is the intensity of electric field? So sorry for this, please. Okay. Intensity of electric field means what? The force experienced by a unit positive charge placed at that point in the field is called as intensity of electric field. So for example, let there is a it is a positive charge group of charge around it. Up to this region electric field is there. If you bring one unit positive charge, unit means whose magnitude is 1, let it is a unit positive charge. If you bring and if you keep it inside the field, then it experiences a force. So this experiencing force is called electric field. It is denoted by a letter capital E, and the formula for E is equals to F by Q, or E is equals to 1 by 4 pi epsilon naught into Q by R square. Next, electric flux. So what is the electric flux? Total number of electric lines of force crossing the surface in a direction normal to the surface. Here, what? Total number of electric lines of forces. So it means, so it is generally denoted by a letter phi. Phi is electric flux. What it indicates? Simply it indicates total number of lines, only it indicates how many number of lines are there. Okay, and those lines must to be perpendicular to the considered area. For example, let I have kept like this one paper. From this side electric lenses are like this. Okay, electric lenses are moving in this direction through this surface. Let these lenses are exactly perpendicular to the this surface. Then how many lenses are passing through this surface and perpendicular to this surface is called electric flux. So we cannot include this line and this line. Why? Because these two lines are not passing through the surface, but only how many lines? 1 2 3 4, only 4 lines are passing. So that is why electric flux is simply phi is equals to 4 Weber. Okay, so like this we have to understand, and here the diagrams also given. Okay, so suppose it is a substance. Okay, for this substance if we take the small area, so here area element area we have to denote with a ds. Why? Because small area is taken, so it is a total substance whose area is s. Here area we do not show with a. Here mostly area is denoted by s only. So that is why it is a s is, if it is s is a total surface area, then if you consider the small portion whose area is always denoted by small ds. Okay. Okay, for example, suppose let it is our surface and its area is ds. So area always we have to denote, perpendicular to the surface, and let the field is in this direction, and these two are making angle theta. Then it can be written as phi is equals to integral. So generally we have to write it is d phi is equals to e ds. Why? Because small flux is present in small area. If you want to know the total area, if you want to get the total area, then simply integrate on either side. Here integration differentiation cancel, we get phi only, so this phi. And here integral e, here dot product will present e bar dot ds bar. So here E bar dot ds bar also written. Okay, so see it clearly. And if you remove the dot product, so we know the dot product formula. A dot b, A bar dot b bar can be written as AB cos theta. So like this here formula is written. Okay, so thank you friends. Don't forget watching this video till the end and subscribing. Okay, thank you.